So now I have the pleasure to welcome Teddy Svensson from JBT, accompanied by Karl Wennerholm from PDSVISION.
Det pilarna där, va? Yep. Okay, good afternoon, everyone. So, my name is Teddy Svensson. I am the engineering manager of JBT's Protein Europe division. I've been with the company for about 10 years, but started out as a mechanical engineer about 20 years ago. And my interest in PLM was sparked about 15 years ago when I was introduced to another system. I don't know if I'm allowed to say that. Team Center. Sorry. Where I became a super user and was helping out with the data validation for a few years. But then when I joined JBT, it was a complete new world for me with Windchill and Creo and multi-CAD software. With me on stage, I also have Karl Wennerholm from PDSVISION. He will detail a little bit more about our project that we did. I will start out by talking about who is JBT, because it's a company that maybe not very many people know about, but I can guarantee you, all of you have been interacting with products that come from our equipment. So just think about what you have been eating today or been drinking this morning at the breakfast. So JBT, our equipment, we freeze over 50% of the frozen food in the world. And in our beverage division, we squeeze over 75% of all the citrus juices in the world. Massive numbers. So, we at JBT, we are a key player in the value chain from the farm to the customer, where we supply the global food and beverage suppliers with their equipment. We have about 140 years legacy with innovation, started by a man, John Bean, hence the name, John Bean Technologies. And during these 140 years, the company has grown dramatically to now being a $1.6 billion revenue company with over 24 different manufacturing sites around the globe and over 5,000 employees worldwide. We produce a lot of different types of equipment. So as I mentioned, citrus extraction is one of the big ones. Then we do canning, filling, pasteurization equipment. And in the division that I come from, in the protein division, we handle all kinds of proteins. We do marination and preparation. We coat, fry, cook, freeze, and package. So a key supplier, full solutions provider for our customers. So the engineering team here in Europe, we are responsible for about 25 different equipments. We have plus 200 projects each year that are completely unique, completely bespoke to the customer's requirements. We have a multitude of options based on what kind of product the customer is going to produce. We, of course, have a number of options based on the customer's site or location, like voltages or special factory requirements. And then, of course, we have customer very unique options sometimes that we have to take in account. So, we definitely have a big use for a PLM system with our complexity. So, together with PDSVISION, we did a proof of concept in 2016. And finally, after management agreed, we had a pre-study started up in 2019. And the project officially kicked off in August of 2019. And you can see some of the members here, and we have some of our members with us here today. So in August, that kickoff. And it took us around 3 years. And in October of 2022, we finally gone live. There was a few hiccups, of course, but overall a big success. we managed to continue just as normal, pretty much. So we also did a lessons learned session in 2023, celebrating the success and also taking notes of what could we have done and what could we have done better. So with that, I'm handing over to Kalle to talk more about the project itself.
Thank you, Teddy. So my name is Karl. I'm with PDSVISION and has been with PDS for about 6 years now. I joined the project with Teddy from the beginning. And this project was really about replacing their old PLM system called MoveX10. To just summarize a 3-year project in a few minutes here, it's a quite delicate task, and I will do it with the help of a few topics. So we will go into some technical solutions, at least a few. We will talk about the lessons learned and some of the insights we had from that. And I will also reveal the secret, or it's not secret, the key to success for this project in the end. So we were replacing what was called MoveX10. That was their PLM/ERP system. And as you can see, it looks like a command prompt, really old. And this system had been with JBT for 20 years, I think.
Yeah, minimum.
Yeah. And evolving over time, of course, being becoming the central hub for data management and involved in a lot of business processes. If we zoom out a bit here and look at those dependencies to other functions, Windchill was still around, but it was used as a CAD vault, which meant that we had a manual registration of parts and bill of materials in MoveX10. There were also a lot of tools written in Visual Basic. An example of that was the initiation of new CAD models, where data from MoveX10 helped the user to create a new CAD model or a new CAD assembly in the correct way. So that was also depending on MoveX10. MoveX10, again, was involved in the release process of drawings. So in that release process, the stamp that you can see here, not approved, was removed. Data was also added to the drawing header, and the drawing was then republished and put into a drawing archive on disk, that is. And that drawing archive could then be consumed by a viewer. I think this viewer was also a Visual Basic tool. And the list goes on. There was order configuration done in MoveX10, reporting, change management. There was integration to MoveX12, the pure ERP system, and much more. So with the task to replace MoveX10, obviously all the other functions here will fall apart. And this really becomes the scope for this project. So how do you replace a system like that? Well, it becomes a migration task, of course. And not only migrating data from MoveX10, but also from disk. So there were documents stored on disk. We talked about the drawing archive as well. And we can talk about migration all day. I will keep it simple. I want us to focus on how we can find a way of migrating data so that we can have a new way of working. And how the migration result, the sort of product data model for JBT that we end up in supports the new way of working. And there is a lot to consider here. We do have already in the CAD tools an approach or an aim to have CAD-driven parts and bill of materials. Not only that, Teddy mentioned we have a multi-CAD situation with Creo, Inventor, AutoCAD.
Solid.
SolidWorks. And all those should also produce the same end result in Windchill. That was the aim. Legacy data, of course, as always, legacy tools, as you saw. In Windchill, we had to support BOM management in general, overpopulated bill of materials to enable order configuration in Windchill, a change management process to sustain the data quality and to be able to make changes in a controlled way, and digital thread overall also meant that we want to send this information to the ERP system and additional consumer portals in the end to make use of the data all the way. So let's look at some of the highlights that we developed, or solutions that we developed, and some are high, some are low, but all are very important for this to work. Starting off with line numbers, and line numbers might seem like a small topic, but it can be really tricky, especially if you deal with legacy data. And line numbers or positions are utilized throughout the system, and is an important role in CAD and all the way to ERP. So if you are updating a legacy drawing, you will find the positions already on the drawing. But those are dumb numbers, just a sorted list, and there's no way to translate that into Windchill in a good way. So we came up with a function in Creo to actually export that information, and then in turn import it into the CAD assembly model tree. That way we could then use those numbers in the drawing with an updated format in a smart way. The same numbers from the assembly, from the model tree, could also be translated into what we call line numbers in Windchill. So this is a big time saver for users when they update legacy drawings. And we have a similar solution in Inventor as well. So we capture and produce the same bill of materials with line numbers. To support the users in initiating new CAD models, we did implement Creo classification from My PDS applications. This was something they were used to have, and it's also good support to select your parameters from value lists, and this was replacing also a Visual Basic tool that they had before. In the same way, we did develop a solution in Inventor to support the users, and we used iLogic for that. And again, I mean, we want, regardless if you are a Creo user or Inventor user, you should end up with the same parts and bill of materials in Windchill, and this really makes that happen, to have good quality already in CAD. Material management is a big part for JBT, and when I say material management, I mean material parts being part of the bill of material, and material management starts already in the CAD tools. This was a manual process in MoveX 10, the old PLM system, and we had to find a more efficient, user-friendly way of doing this. And the example here is features in both Creo and Inventor to enable the users to select a material. So from these buttons you see here, the user is redirected into Windchill and to our material part library. And that's maintained or managed with Windchill classification or parts link. So that will enable the user to just navigate throughout the classification nodes, refine the search with classification attributes, and narrow down the list of materials. And then by a right click here, there you go, select the material. And that would actually transfer material data from that material back to the CAD model, populating some parameters. And to go all the way here, at check-in for that CAD model, we would produce a part, of course, but we would also use the material parameters here to add a material part to that mechanical part. And we do also capture what we call the material dimension here, the quantity needed of that material. And material parts here are profiles. It can be a sheet of a certain thickness, so it's not a material quality only. And this is what it looks like in Windchill when we are done. And this is, of course, then consumed in ERP later on. Going back to this picture and just continue the journey here into Windchill and to highlight some of the solutions we selected in Windchill. Order configuration is also something that is really important for JBT and an important capability for a PLM system. This was done in MoveX 10, and we had to not only migrate but to convert it into windshield functionality. And we did end up with 20 or so overpopulated bill of materials from the migration and from the conversion. A thing that is a bit unique for JBT is that these are used as templates, which means that for each new customer order, we actually make a copy, our own copy for that customer. And the reason for this is that we take this copy and then we do some engineering to order to update that to meet customer requirements, because we always have customer requirements as well. When that is done, we can then continue to a more configure-to-order approach. Using options and variants in Windchill, we initiate the configure process, and through a variant specification, the recipe for that configuration, we end up with an order part, a full bill of material for that customer order. As a final touch here, we also create a baseline, a snapshot of that, to keep track of the as-built configuration. So every order, every equipment we deliver has a baseline, and we can know how that was delivered. So we are talking about the digital thread here, and this project was also not only aiming for creating parts and bill of materials from CAD, we wanted to go all the way to ERP. So yeah, creating parts from CAD, and then from promotes or change notices, triggering a message through the ERP connector in Windchill to the ERP system, being MoveX 12 here, was really important. And I think since we went live 1.5 years ago, thousands of messages has been sent to the ERP system. Just a huge time saver and a big quality improvement as well, of course. Back to this overview here, and on the technical side, just to show you some of the tools we have on the consumer side. And we obviously need ways to consume data, and data also needs to be packaged and presented in the way so that we meet the requirements of the consumers here. And we did implement Search Portal from MyPDS Search for this solution, and a few versions of it actually. We do have something called JBT Search, that's the general search engine or search portal to present bill of materials and related documentation. That will also include a reporting section where you can generate parts list, you can generate drawing packages for different levels, reports related to the order configuration process, and more. The order process also has its own search portal, so we can search for legacy orders here, again using those baselines we create in the order process. There is a technical documentation portal to retrieve spare part documentation and also customer drawings, etc. And finally, just a simple drawing search where you can add a drawing number and you will get the drawing, the published drawing for that, and also the revisions of that drawing. So to summarize here, with solutions and many more that I've shown you here, we were able to go live and close down this old MoveX 10 system and start using a new improved way of working. And we have done ever since. So this was 1.5 years ago since we went live. A few months after the go live event, we did a lessons learned, just to briefly share some of the takeaways from that. So this was obviously a big project. We did a pre-study before we started, but we agreed that more time should have been spent in that pre-study to improve on estimations and to improve on expectations internally as well. This project kept growing throughout the journey. Something that might have come out from that pre-study and would have been nice to see is to identify, could we have done this in smaller pieces? We went live with one big bang. And that was also not only tough for the project and the members, but also for the users. Lots of changes to the way we were working, the tools that we were using. And as the third point here, we didn't really spend enough time on training, prepare and deliver. And so many new methods and processes, we did really struggle in the beginning. Yeah. On a positive note, we did a successful go live, and that was due to good planning. We had good coordination, and we also did the rehearsals beforehand. So this is something we can repeat the next time we have a project of this size and maybe improve. There were some hiccups. And as a final takeaway from the lessons learned is that we actually did the lessons learned. That's not always the case. And I think everybody that participated thought it was really a positive experience. We could be transparent about the outcome of the project, and just going out for dinner was a positive thing. I'm a bit of a space nerd. I watch rocket launches, and I'm always amazed on how we can deliver as people projects like that. And I'm not saying that this project at JBT was rocket science, but it was quite close. It was a complicated project, and the key to success is really to have a great team. Many different skills, good leadership, and I want to show you this also. And you mentioned it, Teddy. Many of these people are in the room right now. So if you see any of these faces in the bar, please reach out, and they will tell you more about this project. There is so much more to elaborate on. Will you summarize, Teddy?
Yes. So, as a quick summary of what Kalle just talked about is, in the past, we came from an obsolete system. We had dual systems or multiple systems. We had a lot of manual transfers of data. And I use the word limited, but I almost want to say a broken change management process. It was strictly developed for product lines that we had been using for a long time. But JBT is a growing company, and we acquire companies and we integrate new companies. Then all of a sudden the change management process didn't work anymore. But nowadays, we now have a full integrated system with all the CAD data, item data, and BOM management collected in one system. We have our overpopulated bill of materials that we can configure to order. And we have a full integration to our ERP system where data is transferred automatically upon a release. So what do I see in the future? A little bit about the digital thread itself, that data should flow all the way from sales through engineering operations and to our customer care team, and then hopefully flow back to the design process. So digital thread, digital twin, and then my final slide would be one JBT, since we have so many different sites around the world. But before I go into that, I'm going to mention some of the ongoing development that we have right now. So we're just now working on, or I think did we launch it? No,
No, not yet.
We're very close, yeah. A component management platform. So a portal that makes it easier for all the users when we need a new component, and some governance for that component to ensure data quality and good documentation. That has been mentioned a few times here, that data quality, it's vital. And we just started a pre-study on the Windchill smart platforms, and we have already reached a milestone where we managed to get CAD models generated from a configured bill of material. So I'm really looking forward to that development. So the digital thread. This is a picture from the PTC website, I think, and I think it's been shown a little bit earlier today. So, as an mechanical engineer, our design team, we work with Windchill. We create all our data in that system. We have our own IoT and service platform called OmniBlue. So we collect machine performance, and we want that to be able to be fed back to the design team. And then we want to have the data flowing through all of our different systems, from electrical CAD, mechanical CAD, sales, and what's it called, ERP, and for our software. Now, digital twin. To be able to have that digital representation of an asset inside of Windchill, to be able to maintain that product and having updated as maintained configuration, so we know exactly how does this machine look when we ship it, how does this machine look 20 years down the line. Could be a vital step for our customer care team. And then one JBT. As I mentioned, we have 25 plus manufacturing sites across the world. My focus area is, of course, on our protein division, where we have a handful of manufacturing sites manufacturing very similar products, in some cases even the same products. And I see a future where we are all connected and having that one true source of information coming from Windchill. With that, thank you, and open up for questions.